Alright, these are the solutions to the quadratic algebra test you completed recently, so let's start on the questions. Alright, so question 1, what we needed to do here was fully factorise the following expressions. So looking at this two-term expression here, what we'd be looking at is highest common factor of this and this. So we note that 3 goes into 6, so we're going to pull out 3. Both terms have x in it, so we're going to go 3x equals x take 2. For this one here, we're going to look at it, and it's a trinomial, so the first thing I'm going to do is attempt a cross method factorise of it. So these two are going to be x and x to make up the x squared, and this one here, I'll be willing to bet, is going to be a 9 and a 2. Now, we need to have positive 18, negative 11, so both of these are going to be negative. Let's just test it. We've got negative 2x there, and we've got negative 9x there. When they get added together, we've got negative 11x. So let's put this into the binomial products. X take 9, x take 2. This one here was tricky, and a lot of people, or a lot of students, didn't get this one. So the first thing to note is this is a subtraction. We've got a perfect square, and this easily can be turned into a perfect square. So we're going to rewrite this as 2x all squared, take away x take 3 all squared. Now if you recall the DOPS identity, it is a, let's get rid of that, a squared take b squared is equal to a take b, a plus b. So we're going to treat this as our a, this is our b, and we're going to write 2x take away all of x take 3. So a lot of you guys didn't include that in brackets at your peril. The other one's going to be 2x plus x take 3. Now that one doesn't have to be in brackets because it's adding that and it's adding that. The only time you have to really worry about the brackets is if you're removing a whole bunch of terms. Alright, so what we're going to do now is see if we can clean this up a bit. So we're going to go 2x take x plus 3, 2x plus x take 3. That is going to be x plus 3, and this one is going to be 3x take 3. And it looks like you've factorised it, but not quite, because what can happen here is we can pull out a factor of 3 here, and so this is where the third mark was going to come from here, x plus 3, 3 brackets x take 1. Most people will put that 3 right out the front, so we're going to go 3 x plus 3 x take 1. Some students chose to expand the perfect square and to then use the cross method to attempt to factorise, but a lot of you messed up the subtraction on the perfect square expansion. The best way to approach this problem is using DOPS. Okay, this one here noted that this was in factorised form, and we wanted you to put it into the two other forms, which was general form, so ax squared plus bx plus c. So what we had to do that is expand that, and you guys did this well. So x squared plus 2x take 4x take 8, which is y equals x squared take 2x take 8. We also wanted it into turning point form, which would require completing the square on this, on that one there. So what we're going to do is say y equals x squared take 2x, halve it, square it, so we're going to add 1 and put that all in brackets, and then subtract 1 and then subtract 8. That's y equals x take 1 all squared take 9. So this is the graph that we were talking about there. That's that one over there. So the x-intercepts are at the coordinates, so you can just let that equal 0 and apply the Null Factor Law. So that's going to be at 2, 0, sorry, negative 2, 0, I can't read my own writing, that's negative there, and 4, 0. Okay, the y-intercept is at the coordinate. The y-intercept can be picked up very quickly in general form from this one here, because the y-intercept occurs when x is equal to 0. So y equals 0, take 0, take 8, y equals negative 8. So when x is equal to 0, y is negative 8. Right, the axis of symmetry will run down the center point of these numbers here. So if I simply add those two numbers together and divide by 2, so 4 plus negative 2 all over 2, which is negative 2 on 2, that's going to be x equals negative 1. And the coordinates of the turning point, well, this is the turning point here. What that does is this moves the standard y equals x squared parabola 1 unit to the right and 9 units down. So the x squared parabola will have a turning point there. It moves it 1 to the right and 9 down. So the turning point is going to be 1, 9, negative 9. Okay, show that there are no solutions to this. There was a number of ways to do it. Some of you guys chose to subtract 3 from both sides. And then note that to solve for x you had to square root both sides, and you can't square root this. So we would say something like this. The square root of negative 3 is not real, therefore no solutions. A number of you guys expanded that, so what you guys did was said 0 equals x squared plus 4x plus 4 plus 3, 0 equals x squared plus 4x plus 7, and then you guys ran the discriminant. 16 take away 4 times 1 times 7. Discriminant is 16 take away 28 equals negative 12. And you needed to just say discriminant less than 0, therefore no sols. Either of those was perfectly acceptable. Alright, so what we want to do is make this a perfect square. So just remember what a perfect square is. That's a perfect square. That's a perfect square. That's a perfect square. That's a perfect square. All of those are examples of perfect square. And so essentially you need to have a rudimentary understanding of complete the square and the purpose of it. Okay, so you'll recall that before, when I put that into turning point form, over here what I did was completed the square. The way I worked out how to complete the square and to get this part, you notice how this is the perfect square. To do that, what you do is you halve this number here, and then you square it, and then you add it. Alright, so half of this is 1, square it is 1 squared, and I've added it. So what we'll do to make that one a perfect square, this a value needs to be obtained by halving that and squaring it. Okay, so a is going to be 5 on 2 all squared. A is 25 on 4. Not many of you guys got that one. Alright, the axis of symmetry here, well, the easiest way to get the axis of symmetry is to use x equals negative b on 2a. So what we're going to do is negate the b value, which is 10, so negative 10 is just 10, and 2 times 0.05, the a value. Now many of you were unable to do this. Okay, so that's 2 lots of 500ths, that's 10 hundredths. 10 hundredths are the same as 1/10, 0.1. Multiply that by 10, multiply that by 10, x equals 100 over 1. Or x equals 100. So many of you lost marks on that, not because you didn't understand axis of symmetry and how to use that formula, but rather you couldn't work with the decimals. Okay, so here's Tenchi's graphs here. So what he's done is made a whole bunch of quadratic graphs from this picture. So here's the original, y equals x squared. That's this one here. Okay, and note that what we've got is a turning point at the origin. Alright, so all of these other graphs have exactly the same shape as this. They've just been moved around the Cartesian plane. So let's have a look at graph 1. It's the y equals x squared parabola, and it's been moved 1 unit to the right. Now, a lot of you thought that was moved 2 units to the right. You just need to check your scale. Alright, and make sure you understand that this is 2. That means that must be 1, that's 1.5, and that is 0.5 there. So what I note is graph 1 equation is going to be y equals x take 1 all squared. Okay, and what this does is it moves the y equals x squared graph 1 unit to the right. Alright, graph 2 here is this inverted x squared parabola. So I'm noting that to invert, it's going to be negative x squared. And also, what's happened to the turning point? It's not just inverted and going through there. The turning point is moved up 1, 2 units. So our function is going to be y equals x negative x squared plus 2. Right, and his final graph in the pattern is simply the y equals x squared graph moving 1 unit to the left. Okay, and moving to the left means we're going to do this. Alright, some of you struggled with the sketching of this graph here. So remember Tenchi's rule as well is always check for common factor. We have got one here. Now what we're going to do is work out the x-intercepts. They occur when y is 0. And this is all ready and set up for the null factor law. X equals 0, x equals 4. So there are the x-intercepts. I know that the axis of symmetry is going to run along this line here. Alright, so I've just got to find out what the y value is. So I'm going to substitute it into the formula. So y equals 2 squared take away 4 times 2. Y equals 4 take away 8. Y equals negative 4. So the turning point is going to be 2, negative 4. So I can put that wherever I like on the y-axis. Let's just see how this goes. I'm drawing this on a pad, so it's hard to actually do because I'm not drawing it straight onto the screen. I've got this pad next to the computer that I'm writing this on, and I actually can't see where those points actually are. So, in my opinion, that's not bad. Not too bad an effort. Okay, we've got to label these coordinates 0, 0 and 2, neg 4. Alright, this one was a tricky one. So you've got to label all key features. So many of you, I think, dived in and tried to do the cross method, and you would have found pretty quickly that it won't work. Noting this here too, this negative x squared means that it is an inverted parabola. We have got a y-intercept of negative 7, so that is of interest to us, so we can put that in at negative 7, and that occurs when x is 0. Alright, so what we could do is actually test how this works, and now what if it's inverted? It could go like that, so it still could have x-intercepts. That's definitely on the agenda. So let's test it out. So what I'm going to do is run the discriminant on it. Alright, so what I can quickly see here is it's going to be 64, and what's going to happen is 7 eighths of 56, 4 lots of 56 is going to be a large number, larger than 64 anyway, so it's going to be 64 take away a bigger number. So at this stage here, I know it doesn't have any x-intercepts, and I don't really need to continue doing the discriminant. I'm only doing that to test whether it's got x-intercepts, and this is really, the 2 marks come from sketching the graph, not from actually you're working out. So you don't really need to sort of go formally, oh, the discriminant is negative, therefore no x-intercepts. This Now, you've just ascertained that there's no x-intercepts. So what I know will happen is it's either going to look like something like that maybe, or like that with no x-intercepts. So the best thing I can do now is find or calculate the turning point. So the best way to do that is x equals negative b on 2a. X equals negative 8 is 8 over 2a is 2 lots of negative 8. That is negative a half. So negative a half. So the tough part is going to be that it turns somewhere along that line there, and I just need to work out the value. So I've got to sub in negative a half into this, and that's a little bit of a tricky substitution. So y equals negative 8 a half squared, take away 8 times a half, take away 7. Okay, this is a quarter. Quarter of 8 is negative 2. Half of 8 is negative 4. Take 7. That is going to be that's negative as well. Sorry about this. That's definitely negative 2. Negative, that's going to be plus 4. Negative 2 plus 2 is negative 5. Okay, I think I've got that right. 2, negative 3, negative 4, negative 5, negative 6. So the scale looks alright. So my point's going to be somewhere out there. So excuse the graph. This is just to give you a general idea. Okay, and again, that's not the best effort, but it is hard to get this thing right. So that's not looking very parabolic at all. And at this point, I'd probably sort of say to myself, actually, you know what, this scale here is just not looking particularly good. And so what I might try to do is actually sort of spread these values out a bit. Okay, so I'm actually going to do that. So at this point I've sort of declared that I'm unhappy with the way that looks. Alright, so a couple of things that I can do. What I can do is put the negative a half in a bit closer. I'm going to put the negative 7 down there. So I'm going to go negative 1, negative 2, negative 3, negative 4, negative 5. Negative 5 is going to go in there. Alright, and that's a bit more of a respectable effort. And there's my coordinates labelled. Okay, so for this one here, we've got a graph, and I've actually drawn it for you. So that is the graph. So all you had to do was mark the key features. So we could get the y-intercept pretty easily. That occurs when x is 0, y is negative 1, and we just get that from the constant there. The turning point, so that's x equals negative b on 2a, x equals 5 over 2. Now we need to substitute that into here, so we're going to go y equals 5 on 2 all squared, take away 5 lots of 5 on 2, take away 1. 25 on 4, take away 25 on 2, take away 1. Oops, 4 over 4. So I've just found a common denominator there. So that's going to be y equals negative 29 on 4. Okay, so when x is 5 on 2, y is negative 29 on 4. Right, so the last thing we need is the x-intercepts, and it's not looking good for the cross methods, so this is going to be a quadratic formula. So x equals negative b plus or minus the square root of b squared take 4ac all over 2a. X equals negative b is 5 plus or minus the square root of b squared. 25 take away 4 times 1 times negative 1 all over 2. X equals 5 plus or minus root 29 on 2. So this one here is going to be 5 minus root 29 all over 2, comma 0, so that's the x value, and this one here is going to be 5 plus root 29 on 2, comma 0. Now that question was done pretty well. Right, this one here, the line y equals 8 intersects with this. We want the coordinates, so we're going to go 8 equals, so we're going to let them equal each other. So this says y is 8, so we're going to swap 8 and y. X squared take 4x plus 3. Now we're going to attempt to solve that. To do that we need to use the Null Factor Law. Okay, so I've subtracted 8 from this side, subtracted 8 from here. Let's set up the cross. Alright, so those are the two values. Now the question says as coordinates, so it's negative 1 and it's 5. Those are the x values. Now a lot of you put in 0 here, but that's not true. The coordinates of the point of intersection have to be the line y equals 8 and this graph here. So it's going to be when x is negative 1, y is 8. When x is 5, y is 8. Right, so this one here, for what values of k does it have one intersection with a line? Now there's a couple of ways of doing this. What I quickly did here was I completed the square on this. So what I did was I got it into turning point form. So I go x squared take 4x, halve it, square it, and add it, and subtract it. Alright, y equals x take 2 all squared take 4 plus k. Right, so what's going to happen is this has a turning point here, and the turning point here, this one here needs to be along the line y equals 8. So what needs to happen is that needs to happen on the line y equals 8. So what we're going to do is this value here needs to equal 8. Okay, it needs to go 2 to the right and 8 up. Okay, so this value here needs to be 8. So negative 4 plus k needs to equal 8. K must be 12. Okay, this one here says the equation of the graph shown has irrational solutions. Alright, so here are the irrational solutions. Many students went for this one here because maybe they thought that's irrational. 7 on 2 is 3.5, completely rational number. This one here moves the turning point 2 to the right, 7 down, 2 to the right, 7 down. That's where that turning point will be. No way. This one here is an inverted parabola, so that looks like that. That's an upright parabola. No. This one here is a possibility. This one here has rational solutions. It's not a possibility. It must be this one here. Okay, we've got this one here, x squared plus 4 equals 0, and what we want to do is work out the value of x. That's x squared equals negative 4, square root, can't square root a negative number, x is not a real number. Alright, this one here, we've got a triangle that has a height of x plus 4 and an area of this. Recall that area is base times height over 2. So we've got a half x squared plus 3x plus 4 equals the base, which is what we don't know, multiplied by x plus 4 over 2. Alright, so the first thing we're going to do is we're going to multiply this side by 2, so we're going to get x squared plus 6x plus 8 equals b times x plus 4. Alright, now what we're going to do is attempt to factorise on this side, so let's use the cross, x, 2, 4, and both of them are going to be positive, so that's x plus 4, x plus 2 equals b times x plus 4. Now, I'm going to divide both sides by x plus 4, which means that will cancel out with that, means b is x plus 2. This one here, a lot of students got this one wrong for one simple reason, is a lot of you just assume that's the a value, that's the b value, and that's the c value. Alright, so in this case here, our a value is m, our b value here is d, and our c value is g. Alright, so needed to be aware that's in this form, mx squared plus dx plus g equals 0, gets it in the form ax squared plus bx plus c equals 0. Alright, in which case it's going to be, well, let's write the quadratic formula. It was given to you. Negative b plus or minus square root of b squared minus 4ac over 2a. Alright, so this b value here is this b value. That's going to be replaced by d, so x equals negative d. Plus or minus d squared, take 4 times the a value, in this case is m, and our c value is g. And we've got a solution. So I don't even need to look at that, but this is 2a, the a value in this case is m, it's going to be 2m. Alright, a lot of students got this one wrong as well. So this looks like it's got a turning point of 3 based on that, and negative 3 on 2. But recall with these big square brackets here, what we do is we multiply, or use the distributive law here. So this is the same as y equals negative 4x take 3 squared. We're going to do negative times a negative, which is a positive. 4 lots of 3 on 2 is 12 on 2, 12 on 2 is 6. The turning point is 3, 6. Tough question that. You could have graphed it and had a look as well as another method. Right, the graph of a parabola is shown below, and the rule could be. Okay, so what we've got here is a graph with the axis of symmetry as a. So if I did x equals negative b on 2a, what would happen is my answer would be x equals a. Alright, so essentially what I'm looking for here, if I expand this first problem out, I've got negative x squared take plus ax. Alright, and what I'm looking for is for this to have a, how to describe this? I'm going to write down my a value here, which is negative 1, my b value here, which in this case is a, and my c value in this case is 0, c equals 0. It's not important with this, with x equals negative b on 2a. Alright, now what I'm going to do is then sub in my values. So b is a, so I'm going to write x equals negative a. And 2a, I'm going to do 2 lots of what a is, which is 2 lots of negative 1. So 2 lots of negative 1 is negative 2. So that's equal to a on 2. That's not the axis of symmetry. The axis of symmetry is a. So I'm going to try this one now, and again it is a process of elimination here. Alright, so I'm going to go negative x squared plus 2ax. Alright, now I'm going to write out my values. A equals negative 1, b equals 2a, and already I'm getting a better feeling about this one here. So it's x equals negative b. Negative b is 2a, so I'm going to write 2a, negative 2a. And 2 lots of a is 2 lots of negative 1, which is negative 2. They cancel out. X equals a. We have a winner. You could have ruled out these two automatically. They're upright parabolas. This parabola is inverted. Okay, so that's another thing you could have certainly done with that. Alright, on to the analysis questions. Notice I haven't actually used my calculator at this stage to do any of these problems. Question 5, you could have graphed that one on the calculator and worked out what the turning point was. This one here, I'm not sure how you would have worked that one out on the calculator. That one, yeah, really did need to be by hand. You could have factorized that, but it's quicker to do that by hand. This one here, you could have run a solve on that, and it would have told you not real. This one here, you could have, if you suspected that had irrational solutions, you could have banged that in for a solve. So solve x squared plus 2x take 7 equals 0, comma x. And what you'll quickly see is that's the only one that would come back if I attempted a solve on it with irrational solutions, that is surds. Alright, on to this problem here, and a bit of a plug for October Sky. It's a good movie. Alright, so Daniel is attempting to launch his own rocket. Been working on it for months, and yeah, launches the rocket, and it's modelled by this equation here. So let's have a look at that. Now, what I'm going to quickly do is I'm going to graph that. So let's go over to main rather. Come on, menu. Is it going to do it for me? Okay, yes it is. So graph and table, and we're going to go 30x take away x squared. So click it and graph it. Alright, and I haven't got much. Alright, so the first thing I'm going to note is what this parabola might look like. So I'm just going to quickly factorize this. So h equals t, 30 take t. So what that's going to do is that means t equals 0 and t equals 30 are the x-intercepts. So I'm going to hit this button here and change the x-min to say negative 10 and the y to 40 to encompass the x-intercepts, which is 0 and 30. Alright, now what I'm going to do is I'm going to note that the y-intercept is at, the axis of symmetry will run along 15. I'm looking at the max here, so I'm going to at least start at, say, negative 10, just a bit below the x-axis. 105, I don't know, maybe it does go that high, I don't know, let's see what it looks like. So I'm going to hit OK. So there's the rocket taking off from there, and it's launching, and it's going to turn somewhere over there. That's 105. So I'm going to double 105 and see what happens. So that's 210. Whoa, nice launch of a rocket there, Daniel. And what we're going to do is continue to increase that. Let's go 250 and OK, and I finally got it. Okay, we want the height of the rocket after travelling for 5 seconds. Analysis, G-solve. I want the height. Height is the y-axis. after 5 seconds. 125 meters. How long after launch does the rocket land back on the ground? Analysis. G-solve. Root. That's where it launches, it lands there. So I'm using the left and right, or hitting this button here. Alright, so that happens at x equals 30, which we knew would happen over here anyway. So how long after launch does the rocket land back? After 30 seconds. What time does the rocket reach its maximum height? So that's where the turning point is. So I'm going to go analysis, G-solve, and I'm going to use max. Alright, max occurs at 225 after 15 seconds. Maximum height achieved was 225 meters, as we established. Sketch the path, or sketch a graph showing the path taken by the rocket. So we've got time and height, 30, 15, 225, 0. Right, so again you're going to have to excuse that graph because I can't quite see what I'm drawing on, and so it's very difficult to draw that with any sort of accuracy. 30, 0, 0, 0, and the turning point is at 15, 25, 225. Find out what times the rocket reaches the height of 200 meters. So what we're going to do is go analysis, G-solve, and what we want is an X-calc, and it's going to say for what Y value or for what height, in this case 200. So it's 10, so it's after 10 seconds. And what you need to do is hit right on your calculator here, so you can get the second time, and that is after 20 seconds. For how long was the rocket at least 81 meters above the ground? Alright, so again we'll go analysis, G-solve, and we want to know how long. We want an X-cal, and it's going to say for what height? 81, thanks. Got that round the wrong way. There you go, analysis, G-solve. What we want is a X-cal, yeah, that's what I want, for the Y value, 81. Oh, don't know what happened there, but anyway, so the first time it goes, or it hits 81 meters is after 3 seconds. And then I'm going to hit the right button, and 27 meters is when it dips, 27 seconds is where it dips back below 81. So between those two times, between 3 and 27 seconds, it was above 81 meters. So what we're going to do is simply write what's going on here? I'm just going to pause this for a sec because my pen's not working. Okay, not sure what was happening there. So now what we're going to do is work out how long, which was 27 take away 3, 24 seconds. Alright, so Rosemary is also working on a rocket. She launches hers from the same location as Daniel, but from a launch pad that is 3 meters off the ground, and that's the flight path. So how many seconds longer is Rosemary's rocket in the air for when compared with Daniel's? So what we're going to do is we're actually just going to work out the x-intercepts of hers, okay? And so we know that when Daniel's is fired, it lands there, and so Rosie's we assume is going to be better. It's going to go up, and it's going to land there, and what we're looking for is how much longer. So Daniel's was 30, we want to know that one. So to do this, I'm going to go back into main and get main to factorize that for me. So I'm going to go factor negative x squared plus 60x plus 3. That's not going to do it for me. Actually, what I'm going to do, forget factor, let's go solve 0 equals negative x squared plus 60x plus 3. Okay, so these are the x-intercepts. This one here is the irrelevant one. This one here is the relevant one. So 60.04. So we wanted the answer to the nearest second. So that is that as 60. So we're going to go 60 minus 30. That's 30 seconds. Alright, this one here was a fairly tricky problem. After how long is Rosemary's rocket 48 meters higher than Daniel's rocket? So we want to know when the difference between these is 48. That is, if I say after how long is Rosemary's rocket. So I want the difference between their graphs to be 48 meters. So essentially what I'm going to do is say Rosie take away Daniel, and when is it 48 meters? So this is the way I would set it up. Rosie's function is this one here, so negative t squared plus 60t plus 3, and I'm going to remove Daniel's from that. Daniel's is up here, 30x take away x squared. Alright, so all I'm going to do is solve that. It's just one variable, so let's go into decimal. So solve 48 equals negative x squared plus 60x plus 3, take away, brackets are really important, 30x, take away x squared, comma x, and x, or t in this case, is 1.5. What that means is after 1.5 seconds, Rosie's rocket is 48 meters above Daniel's. Right, so there are the worked solutions. I hope they're of some benefit to you if you got any of those questions wrong. So work hard on those ones and improve in the exam.